Okay, YouTube, in our last video, we introduced the concept of the determinant of a square matrix and mentioned that every square matrix has some real number or scalar associated with it called its determinant. So in the last video, of course, we looked at a very specific method for finding the determinant of a 2 by 2 matrix. We say if A is a square matrix of order 2 by 2 or greater, then the determinant of A is found by doing this. And well, I guess what I would say specifically here, if A is a square matrix of order, what I want to write here is 3 by 3. And basically what I want to mention here is this method you see here only works with 3 by 3 matrices. So this right here only works. I guess I don't want to take up too much of my room over here. Only works with 3 by 3 matrices. And so it's a neat little method here. It means that we don't have to expand by minors and cofactors, which is just a lot of work. It's easy to do. It's a lot of work. But basically, it's a method that will allow you to find the determinant of 3 by 3 pretty quickly. So here's what we're going to do. These steps here. Say you have some 3 by 3 matrix here. It has to be a square matrix and it's 3 by 3. What we're going to do is this. We're going to copy all but the right column on the right side of the matrix. So basically, when you look at all 3 of your columns here, this is the very rightmost column. We're going to take the first 2 columns here. We're going to copy them out onto the right side of the matrix here. And we're not going to copy the 3rd column. So essentially what I'm mentioning here is I'm going to copy the A and the B. I'm going to copy the D and the E from over here, and I'm going to copy the G and the H. And so we have this thing right here where I'm just kind of saying that these kind of sitting out on the right side there. They're not really there. So what we're going to do is multiply the down diagonals and then multiply the up diagonals. And by the down diagonals, what I mean is this. Start in the top left corner. And then we're going to go down to the right. And so essentially what we're going to get here is this. The determinant of this matrix would be equal to, and it's a lot of stuff. So I'm going to put all of this minus all of this. I find comfort in the fact that in the last video, what we did was basically we took the product of the main diagonal minus the product of the opposing diagonal, and that was our determinant. In this video, what we're going to do is a little bit more extended, but it's the same concept. We're going to start with our down diagonals here. So I'm going to take A times E times I, the product of all of this. So I'm going to write A, E, I. And I'm going to add that now to the product of this next main diagonal, which is B, F, G. So plus B, F, G, plus now what we're going to do is one more main diagonal here, the down diagonal. So we say C, D, H, C, D, H. And I call this the down diagonal because we're going down each time to the right. So now as we go through our up diagonals, we're going to start in the bottom left and we're going to move up and to the right. So start in the bottom left corner. And so we're going to start down here at the G. I'll switch my color here. We're going to go up diagonals G, E, C, G, E, C plus now the product of H, F, A. So we have H, F, A plus now this is an I right there, I, D, B. So what a mess here, IDB. But basically, if you wanted to describe this as a motion, we went product plus product plus product, all of that. It's important that you quantify all of that minus now product plus product plus product. So it's kind of like the determinant of a 2 by 2. What I want to do is just kind of see if we can do this here by hand and also check to see how we do this on a calculator, find a determinant on a calculator. So checking this determinant out here, it says find the determinant. So the first thing I want to do is this. I want to rewrite this with vertical bars on the outside. We want to say this is 3, this is 4, this is -2, vertical bar here. So we have 3, 5, 0, -1, 4, and 1. Determinants are always great if you have 1s and 0s on the inside. We'll look at this and talk about why. But I'm going to recopy now 3 and 4. I'm going to recopy 3 and 5. I'm going to recopy -1 and 4. And these are basically just these columns right here that I'm sticking on the outside. Just they're not really there, but we're going to represent them out there anyways. And so we say this determinant here, I'm going to write equals, and again I'm going to write this whole sum, whoops, I said sum and I wrote a sum, this whole sum here of products minus the sum, the sum of the other products. So let's go ahead and rock this out here. We say, starting at the top left, our down diagonals, we say 3 times 5 times 1 here, that would be 15, so we get 15 plus. Now 4 times 0 times -1, here's why I mentioned I like 0. If there's a 0 there, you don't need to even think about the other numbers. We know that the product of anything containing a 0 as one of its factors is 0. And we say now -2 times 3 times 4 that would be negative 2 times 3 is negative 6, and negative 6 times a 4 is negative 24. So I'm just going to leave that for now. And now what we're going to do is we're going to do the up diagonals here. These are these three right here. We're going to do the up diagonals. So we'll start here on the bottom left. We say negative 1 times a positive 5 is negative 5 times a negative 2 is a positive 10. So we get a 10 plus, now we're going to go 4 times 0. Okay, so that's a 0. And we say 1 times 3 times 4 is a 12. So all we're going to do is just carry out this subtraction problem, really. 15 and a negative 24, I believe that is a negative 9. And a 10 and a 12, that's a 22. So as we said, if we said negative 9, take 22 more off of this here. This would be a negative 31 right here. And so essentially, to begin with, we would say if this is the matrix A, this 3 by 3 matrix here, then the determinant of A, which could also be written as the determinant of A, which could also be written as this thing right here, it would all be equal to negative 31. So now, just to make sure that I did all of my arithmetic here correctly, what I want to do is I do want to check this out on a calculator. So for the first time, go ahead and get your calculator, turn it on, and I'm going to ask it, go ahead and put this matrix into your calculator. And so that of course would require that we go to our matrix menu here, turn on matrix, and go over to edit, and then to your A here, and 3 by 3. Now you'll notice that I've already put my matrix in here. But essentially what we're going to do is we're going to quit out of this menu, and I'm going to go back to my matrix menu. In the math portion here, it's the very first option. See, we work with determinants so much in terms of applications that they put it as the first option here. So we say the determinant of A, we're going to go ahead and hit the determinant, and we're just going to go back into our matrix menu and pull A out here. And you don't have to put an end parenthesis on this, but I would recommend you do just to be proper. And then we say, okay, taking the determinant, I see that it is negative 31. So I'm very well assured that we are correct here. And the determinant of any matrix is going to work on this calculator here. So just to go to show, this is going to be a quick fix here, but I'm going to go back to A, and I just want to show you here, what if I were to make A a 3 by 2, which is, of course, not a square matrix. I'll just click on 3 by 2. And if I quit here, and you can see that if I pull out my matrix A, here's my matrix A now. If we were to now, I'm going to hit second enter. 2 times ago I typed this in. And I'll hit this and it says invalid dimensions. So that just goes to show that you can only find the determinant of a square matrix, and using a calculator will allow you to check your work. Cheers.